Hello everyone and welcome to this course, online NPTEL certification course on aquatic geochemistry, and this is the second lecture and I will continue today with the introduction to global water challenges. So, in my last lecture we were talking about water and how it is central to all the sustainable development goals. I explained and I hope that you have understood the importance of water in the fulfillment of all other 16 sustainable development goals. Now, this sustainable development goal had a deadline that had to be finished in 2030. And as per the current 2025 UN report, we are still severely off track of attaining our goals. So, they have yearly goals, bi-yearly, 5-year goals for every SDG, and for this SDG 6 we are severely out of track. And that means we are falling far behind than what we should have happened. Various reasons, there can be economic conflicts, there can be national conflicts and all that kind of wars going on, COVID and everything can happen. So, we are severely off track, and from this term called sustainable development goal, we have also learned a few things wherever things has been applied and all, and we are now slowly moving towards what is called One Health. Okay. And this I would say that became more evident. It was not that it was identified, but at that point, but it became more it became more famous after COVID happened. That is, we slowly started understanding the extent to which all our health is connected. So, initially in those days of COVID, people would ask a variety of questions like, from where did COVID happen, from which animal did it got transferred from, through which media, that is either through air or through water, how is this disease being transferred to from one person to another person. Okay. So, from which animal did this virus come from. So, a common understanding happened, that is a large scale understanding, even to a very person who is living in the most remote places have understood that all our health is now together. It is not that okay, somebody sitting somewhere in Siberia does not get affected to somebody's to some disease that is happening to in another far off place in somewhere in Africa. No, it can be transmitted, it can happen very quickly, as as quickly as COVID-19 got transmitted across the globe and all. So, from water, water is such a media through which diseases can get transmitted rapidly across all forms of life, across from single cellular animals to the higher animals in the food chain. And this concept of One Health majorly takes our focus from only human health, and from human health we slowly started understanding okay, animal health is also important. No, we are now talking about the environmental health. Okay. So, we are talking about keeping the sanctity of our water bodies, of our forests, of the soil, of atmosphere and everything. So, you will see that One Health is a very multidisciplinary concept. So, it is a collaborative, multi-sector and transdisciplinary approach to achieve, the goal is to achieve optimal health and well-being by recognizing the interconnections between people, animals, plants and the environment that we are all living in. And this slowly, we are not slowly, it has been for quite some time, but as the years are progressing, we are seeing the huge and unprecedented biodiversity losses happening all across the globe, and it has been happening at a much rapid scale than at any time in human history. That is what the urgency is right now. So, the biosphere upon which the whole humanity is depending is getting altered to an unparalleled level, something that we have never seen before, and it is happening so fast due to this water pollution, because water is getting transmitted across all spatial scales and at a much faster, and it is getting repeated at much faster in the time scale. So, that is why understanding of water, its challenges becomes so important. Okay. So, what emerging challenges are we now facing? And by emerging challenges, I would mostly talk about the chemical challenges in this particular lecture series. Now, I think you all have heard about this term called water pollution. In water pollution, traditionally we have only measured a few parameters, and mostly by saying a few parameters, I would say that they are of mostly of chemical nature, that is something like pH or dissolved oxygen, and also of biological nature, that is whether there is fecal coliform, whether there is any virus there. So, such assessments are done, but now with urbanization and with industrialization and how humans are progressing as a civilization, our problems are also changing. So, no longer pH, now pH is definitely a very important factor, but other contaminants are also coming into the picture. So, you must be realizing that you as an individual is you are using and you are prone to and you are subjected to much more chemicals than 3-4 generations, people living 3-4 generations ago. So, probably you are using much more pharmaceuticals, personal care products than what your grandparents were using. So, and not only for ourselves, like in general for our domestic life, for for in our regular day to day activities, we are using much more chemicals than what used to be 50 years ago. Now, those chemicals, they are there, okay, they are not like we are using and it is evaporating into thin air, no, their remnants are definitely there. So, they are going finally, if you are washing it off or something, it goes into the water, through the water it enters the drain system, through the sewage system it enters the river channels, or it can enter the lake, and finally if it is entering the ocean, then if anything is remaining, the remnants, depending on the how much of it is remaining, it can enter to larger open oceans and all. So, problem now is that we are now using more and more substances, okay, that is entering our aquatic systems, and these we call the novel entities. Why novel entities? Because these entities did not exist in nature, we are now producing them in industries, okay, and we are starting to, as consumers, we are consuming it, okay. So, the types of contaminants have changed, okay, there are variety of users have come now. So, here is a very small, I have given you a gist of the contaminants that we are now rapidly being found out, we are rapidly evaluating in water systems. So, the first thing I would say, I will start with plastics and disinfectants. So, plastics and disinfectants, I think every household now has a variety of plastic products we are using in our daily life. Okay. And you may have heard about this term called microplastic contamination, and we are now moving into nanoplastics and all that. So, microplastics has been found in even our human tissues like blood and bone tissues, and even the muscles and everything. So, it has infiltrated our system through different either through air or through water that we are consuming and all. So, plastic pollution is now everywhere. Okay. Microplastics are, I think, if you take a sample from even in the depth of the Pacific Ocean, you will still find microplastic in that water also. Okay. Then we will talk about polycyclic aromatic hydrocarbons, that is in short we call them PAHs. Now, they are a form of hydrocarbons. What are hydrocarbons? Hydrocarbons, where are you using? Your oil, your diesel, your petrol, all the kinds of petroleum products, they are your hydrocarbons. Whenever you are using any kind of petrol, diesel based products, some aromatic hydrocarbons are produced during the burning process, during the consumption process. Now, these aromatic hydrocarbons, they remain either in the as aerosols in the atmosphere, or if they are dissolved in the water, they will be there. So, they will have a certain lifespan there. So, these polyaromatic hydrocarbons are coming from generally hydrocarbons, mainly fossil fuel burning. And as you may already know that we need fossil fuels, that is petrol, diesel, we need for every kind of industry. Okay. If they are not or using green energy, that is mostly solar energy or wind energy, then they will be using petroleum, or they will be using some other kind of petrol modified energy source. Others, for example, dioxins, polychlorinated biphenyls. So, these are some other type of chemicals that I am talking about. Dyes and dyes containing hazardous pollutants, organic or inorganic chemicals. Now, dyes, textile industry has bloomed, okay, has bloomed over the last century, I would say. Now, textiles, definitely we are producing many types of colors now, and colors, all of them are not natural. Okay. They are being created, they are being synthesized in the laboratories. Now, these dyes, when they are producing in a mass scale, okay, then these dyes which we are creating from some kind of chemical salts and all that, they get they get released as a waste product via the effluents. Okay. They will go into the sewer network. Now, from that sewer network, if you are treating that wastewater, sometimes it may get removed, and if it is not getting treated, it will get into the natural aquatic systems. So, dyes is a very common pollutant, I would say, because of the demand, the rising demand in the textile industries and the nature of the industry itself, then the number of dyes has increased, our consumption has increased and its production has increased. If production has increased, that means its waste that is being produced has also increased. Pharmaceutical residue, including nutraceuticals and cosmochemicals. Now, pharmaceutical industry is, I think, in its biggest peak right now. I would not say a peak, because it may just go on increasing even in future. We all are now consuming more medicines than ever before. Okay, as humans we are consuming more medicines. So, anybody is sick, now we are more having the access to medicines. Even in rural places, they will have good accessibility to medicines and all that. At least how I am describing this good or bad, it is just with respect to our past. In the past we did not have this kind of accessibility that we have today. So, now we have more accessibility and we are using more pharmaceuticals, and pharmaceuticals can be of different kinds. So, it can be either we are like increasing our nutritional supplementary based pharmaceuticals or cosmeceutical use. So, it is not only the necessary kind of medicines that has to be taken, it can be of the choice, something I am taking by my choice. Okay. When I am taking these pharmaceuticals, everything is not assimilated in my body. It is going out also through the human excretory products. Okay. Now, when these excretory products release these pharmaceutical remnants into the aquatic systems, okay, then those pharmaceutical remnants can start impacting the animals, the fishes, the plants that is living there, because these molecules are prepared such that they target the cells of certain kind, they will have some kind of affinity. So, how when you take a medicine, it targets some kind of cells in your body. So, similarly if it is there in in another body, it can target there also. It does not say, oh, this is not a human, I will not target. So, whenever these remnants are also being dumped into an aquatic system, they can target, they can influence the aquatic life as well. Okay. Then chemical and biological micropollutants from agricultural wastewater. So, water use, okay, if I divide water use, then 70% of global freshwater use goes to agriculture, okay. 20% goes to, it is seen that on average 20% of water goes towards industries and 10% goes towards domestic purpose use. So, imagine the huge quantity of water that is also coming back as waste water from agricultural usage. Okay. Now, in agricultural, what fertilizers and pesticides you are using, of course, if it is not being taken up, then it gets dissolved, released into the aquatic bodies. It will definitely be there in the aquatic system. So, those pollutants, okay, are of the newer emerging kind of pollutants. We are adding more pesticides into the system, we are creating more target biomolecules that have, have an impact on certain kind of diseases and all that. So, more kinds of products that are being used for agricultural purposes, they also get released into the aquatic bodies. Personal care products such as any kind of personal care products, and it can be something like antibiotics, it can be as simple as having a sunscreen or any shampoo that you have been using. So, now these products, they also contain certain chemicals that can influence certain other aquatic life. So, or influence the genes or genetic genetic changes in some other animals, they can do that. So, that is why certain personal care products have been banned in the past, and we are continuously moving towards producing greener products, okay, that which does not directly influence the environment or with any kind of life form. And why is this particular problem so growing so rapidly? You see, every year thousands of chemicals are being produced. So, globally, imagine how many industries there could be there, how many industries they are producing more types of products, they are launching new products in the markets, and we of course consumers, we are using that. In 2018, 28,712 products were registered in New Zealand alone. Now, New Zealand, in comparison to large countries like USA, India, okay, they just imagine the number, the difference, that how many chemicals can get registered in a country like China, in a large country like India, in a large country like USA. Okay. So, every year that number is increasing. Okay. So, if we are still talking about understanding water quality and we are limiting ourselves to parameters such as fecal coliform, pH and BOD, COD and things like that, our understanding of natural aquatic systems will be very, very limited. Okay. So, we are now slowly trying to understand these contaminants, and therefore, we term this as emerging contaminants and emerging challenges. And there has been a study, and this is just an example of one study that was that came out in 2017 in Science of the Total Environment, this journal, and it showed this study, it's a review paper, it's a review article, and it showed the presence of personal care products in aquatic environment and the number of samples that they have taken and the amount, the concentration of the personal care products that has been detected in these countries. And you will see that in some countries there is highlighted, and they have had more number of samples that has been shown in the danger zone from these countries. Okay. And sometimes these results are also a little bit biased, because some other country in some other country may not have the data itself. Okay. So, this again is very data biased, I would say, but definitely it shows us where we are in today's world, that we do need to worry about how our personal care products are ending up and whom it is finally affecting. And we need much more discussions on such topics, and this is not only related to national scales or local scales, we need global policies. These things has to be taken up at global scales, and it has to be both top bottom and bottom up approaches has to be taken up, such that we slowly move towards much more greener, we spend much more on innovating greener drugs, on greener technologies. What do I mean by greener drugs? That means they have less impact on the environment. Okay. Those are termed as green drugs and greener products and all that. So, they are much more less harmful to the environment. So, these are small, I would say this is a very 3-4 papers that I have shown you. If you do a search in the internet, you will find much more details and many research studies that is happening related to emerging contaminants and emerging challenges. Now, moving on to future visions. Okay. That is, what should our future be, what can we start anticipating from now on, and what solutions can we prescribe. In during this fulfillment of SDG 6, certain things has been realized, and that is by 2050 the world population will be projected to be 9.6 billion, and 70% of all people will be living in urban areas. 22 mega cities will be there only in Asia itself by 2030. 80% of the global sewage will still be untreated. In today's world, our increasing chemical access and chemical consumption is faster than our understanding and how it is impacting our environment, and therefore, the interventions that are being implemented are far off the track. Okay. So, you see now in urban places we have seen the variety of challenges that is happening. I think in all major cities all over the world, in some point of the time or other, we have faced an issue of where to dump the waste. Okay. So, if you have seen the history, you will see that in London there was a time when Thames river was full of waste. Then in Paris the river Seine was full with waste, and slowly all over the globe every water body close to in any huge urban center has become polluted. And now our water resources are also getting stressed because of the hydroclimatic changes that we are seeing recently. What do I mean by hydroclimatic changes? So, say for instance in India is observing this huge phenomenon called monsoon. So, we have this Indian summer monsoon. So, that means a few months it will be raining in a consistent way. Every particular day we will see a few millimeters of rainfall, but during certain times of the months we will not see that. So, this is a monsoon period and there is a clear distinction between the non-monsoon period. But now in this recent years what we are seeing that this distinction is slowly being lost. Okay. Specifically in the northern states and in the eastern states, we are seeing very high intensity rainfall. So, it is not that during the monsoon the rainfall is very distributed. We are seeing one day rainfall, it will rain extremely heavily and there will be so much of rainfall that it might flood, and during the other time of the month it will be totally dry. Now, what happens if the rain happens on one day as compared to rain happening every day for 20 days over a month? So, if it is happening rain on one day, there will the infiltration capacity, okay, through soil, through the forest and the grass cover and all that, that infiltration capacity decreases. One day it will rain so much that very quickly that infiltration capacity will be reached and saturation will be reached, and all the water will be just flowing over the land, it will not infiltrate. Now, when it rains gradually every day little by little, then water might seep through and it might recharge our groundwater system. But if more rainfall is happening more erratically and more as sudden bursts of events, then that recharge is disturbed. Okay. And since most of our water use relies on the groundwater because of its stability, okay, then that changes our water availability. So, in any urban city there is population growth, okay, there is infiltration from other places and all. If the water demand is increasing, then our supply has to meet that water demand, and whenever there is that supply is not meeting that water demand, we are saying there is water scarcity. The water is getting scarce and we are not able to meet the water demands. So, we have to this kind of thought that we will take water, we will use it, we will consume it and then we will waste, we will throw out the waste, was a very unsustainable linear kind of model. Okay. slowly we are realizing that we have to move from this unsustainable linear model towards a circular model. That means, in this circular model, we try to use water to its full potential. Okay. We try to treat that water, we try to reuse it again. So, WICER framework, that is water in circular economy and resilience, and this is specifically very applicable for urban spaces, where we use our technology to design out waste and pollution, to preserve and regenerate natural systems, and to deliver resilient and inclusive services. You see, in this image, there are, first part is you take water from the nature. So, when you take water, and there is, of course, there is cities, the industry, and you are using it for this main three purpose, that is agriculture, industrial purpose and domestic purpose. So, after your consumption, you try to recover that water, and what all do you try to recover? So, you will see that water is given in blue, energy is given in orange, and green is our nutrients. So, if we can try to recover the energy, if we can try to reuse the nutrients, and we can try to use it back into our agricultural system, as fertilizers and all, that if we can develop more techniques in recovery, and after recovering we will try to reuse them. Okay, so, something has to be reused, and of course, it has to go towards restoring back of what has been taken. Okay. So, this, if you read detailed articles, you will see how the designing out of waste and pollution is a very big topic in itself. Okay. So, we have to optimize our operations, we have to recover our resources. So, we have to use better technologies, better facilities, so that water is being used, and you can recover the energy from it, you can recover certain metals that was previously being thrown out, some nutrients that you can recover, and we can use that to restore our degraded land or our watersheds. You can use it for recharging groundwater, or you can use it for recycling in some lakes and all that. So, basically you try to deliver back what has been taken out from the system, and this kind of framework increases the resilience of those communities, because then you are not prone to changes in the natural that is due to natural processes like climate change. Now, how much can you control? So, but if you know that okay, if whatever happens, we are going to reuse our water, so your resilience is more. Okay. So, therefore, urban spaces, if we can use more technology and more resources in developing such kind of framework, water's potential, water will be used at its full potential. So, this is the basis of this WICER framework. Another vision is related to, now what when we are talking about this reuse and recycled water, what are we actually looking at? So, we are looking at effluent dominated systems. If you look up more, I would urge you to look up more about this water in circular economy and resilience, and for today I will end here. I will discuss more such future solutions that we should be looking up to, and I will be continuing this lecture module on global water challenges, and I hope you have understood the problems, and if you have any question, please let us know in the live session. Thank you.